Hello, everyone. Welcome back. Today, we're going to talk about solving linear inequalities. So, quick review before we start. What's the difference between how we would treat an inequality sign, so less than or greater than sign, or less than or equal to greater than or equal to sign, versus an equality sign, which is just an equal sign? The only difference about how we're going to treat them is that with an inequality sign, if we divide a negative through the inequality sign, we must flip the sign. So that means greater than becomes less than, and vice versa. And then greater than or equal to becomes less than or equal to, or vice versa. And that's the most common mistake I probably see people making, is just forgetting that when we divide a negative through, we must flip the sign. So keep that in mind. Okay, let's start with example one. So, example one, the first thing I'm going to do is I'm going to get all of our terms with x on the left and all of my terms that are just constant terms on my right. So I'm going to end up with 9x minus 6x on my left and 8 plus 4 on my right, which is going to be 3x is less than 12. Then we're going to divide both sides by 3, and we're going to get x is less than 4. And there we go. There's our answer. Okay. Let's try number 2. Okay, so the first thing I'm going to do here is I'm actually going to expand my 3 into my x plus 7. However, you could just divide by 3 and do it that way, and you'll get the same answer. This is just a preference of mine. So 18 is less than or equal to 3x plus 21, which is less than or equal to 27. Now I'm going to subtract 21 from all sides. So here we have 18 minus 21. Here we're going to have 3x plus 21 minus 21. And here we're going to have 27 minus 21. So over here, we're going to end up with negative 3. Over here, we're going to end up with 3x. And over here, we're going to end up with 6. Then we're going to divide all sides by 3. And notice I'm not saying both sides by 3. I'm saying all sides by 3 because there's 3 sides here. Normally with an equality sign, we just have 2. So we could just say both sides because there's only 2. In this case, we have 3. So it's all sides as opposed to both. Okay. So then we have negative 1 less than or equal to x less than or equal to 2. And that's our final answer. Very good. Okay, equation or example 3 says solve the following inequality. 3x minus 4 is less than or equal to 11 using interval notation. So we're actually first going to find it with set notation because this is already in set notation, and then we'll convert to interval notation afterwards. Okay, so first thing I want to do is I'm going to add 4 to both sides. So I'm going to end up with 3x is less than or equal to 15. Then I'm going to divide both sides by 3 and get that x is less than or equal to 5. So on our number line, that's going to look like this. We're just going to have negative 5 here, and it's going to be everything less than or equal to negative 5. So everything here on this highlighted part. And what would that be in interval notation? Well, that would be everything from negative infinity up to 5. Oh, sorry, I said negative 5. It's actually positive 5. My apologies. Let's switch that. Positive 5. So therefore, the answer is everything from negative infinity up to 5 and including 5. So we use a square bracket, not a round one, because it is possible for it to equal 5 as well. Okay. Let's move on to example 4. Example 4 says, solve the inequality. 12 is less than negative 6x plus 3x minus 1 is less than 18. So first of all, I'm going to simplify our middle term before I even get going on this. So 12 is less than negative 6x plus 3x minus 3, which is less than 18. Okay, and then we have 12 is less than negative 3x minus 3, which is less than 18. Then we're going to add 3 to all sides. So 15 is less than negative 3x is less than 21. Okay. And then we're going to divide everything by negative 3. And when we divide a negative through our inequality sign, we must flip the sign. So we're going to flip, and then we get x here, we get negative 5 here, and we get negative 7 over here. Okay. And then, therefore, we'll say that using interval notation, it'll be everything between negative 5 and negative 7 is the smaller one of those, up to negative 5. So I wrote this wrong as well. There we go. Everything from negative 7 up to negative 5, but not including those terms because we have strict inequality signs, not, ones with that are less than or equal or greater than or equal. We just have strict less than signs here. And so that's why we can't have any square brackets in this case. Alrighty, very good. Let's move on to this one here. This one says, determine if negative 1 is a solution for this inequality. So here we don't actually have to find the answer. All we need to do is find out if negative 1 is a solution or not. So if it is a solution, once we plug it in here, we're going to get a statement that's true. If it is not, we're going to get a statement that's false. So if we get something like 3 is greater than 2, we'd say, oh, well, therefore it is a solution, it's true, because it is true, right? 3 is greater than 2. If we get something like 1 is greater than 2, well, that's clearly not true, and so therefore it wouldn't be a solution then. So let's see what we get in this case. If we plug in x is equal to negative 1, we're going to get negative 6 is less than or equal to 1/2 times 8 times 1 plus 4, and that's the same as negative 8 plus 4, which is negative 4, which is negative 2. So therefore, we end up with negative 6 is less than or equal to negative 2. Now, this is true. This is true. This is a true statement. This is a tautology here. So therefore, x equals to negative 1 is a solution. Now, let's say we got something that was not true. Then we would say it's not a solution. But in this case, it is. Very good. Okay. Here it says solve the inequality and illustrate your solution on a number line. So for ones like this, we could just deal with the fractions if we wanted to. It would work. But one thing we can do here is we can multiply by 12 first. So I'm going to do that. I'm going to multiply everything by 12 first. So we'll get negative 12 over 12, and then negative 12x over 3 plus 12 over 4. And then, this one would just be negative 17. Let's not bother doing that math. So then we have negative 1 here, negative 4x plus 3, and negative 17. Okay, now I'm going to subtract 3 from all sides, and we're going to get over here just negative 4x. Over here, we're going to get negative 20. And over here, we're going to get negative 4. And then I'm going to divide everything by 4. And when I divide everything by 4, I need to swip my signs. So here we're going to get x when we divide by 4. Here we're going to get, or negative 4, sorry. Here we're going to get 1 when we divide by negative 4. And here we're going to get 5 when we divide by negative 4. All right. And so there we go. There we have it. All right. So that's our answer. It's going to be between 1 and 5, including those numbers. So now we've solved the inequality, and it says to illustrate our solution on a number line. So I'm just going to draw a number line like this. And let's say here's our 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our solution is everything from 1 up to 5, like that. And there we go. Okay. All right. And last but not least, example 7. The relationship between Celsius and Fahrenheit is represented by this equation. The daily temperature in Las Vegas in the summer ranges from 78 to 114 degrees Fahrenheit. Write this statement as a double linear inequality. Well, basically, the Fahrenheit degrees must be between 78 and 114. And I'm going to assume that includes those exact numbers, that it could be 78 or it could be 114 itself. So we're going to assume inclusivity here. And then we're going to swap F for the equation, which is going to be 9 over 5C plus 32, with C being the degrees Celsius. And then it says solve the inequality to determine the temperature range in degrees Celsius. Okay, so first thing I'm going to do is I'm going to subtract 32 from all sides. So what's 78 minus 32? That's going to be 46. And then what's 114 minus 32, sorry? That's going to be 82. Okay. Now we're going to multiply everything by 5 over 9. So what do we get for 46 times 5 divided by 9 is going to be, we're going to get 230 over 9. And over here, we're going to get 410 over 9. And then let's find that in decimals. We're going to have about 45.56. And what's 230 divided by 9 in decimals? That's going to be 25.56 approximately there. And so that is our approximate range. I did round there, so it's not our exact range, but that's about the range in Celsius. So that's pretty warm. Even 25, the lower end of that, that's pretty warm. Although that makes sense. This is Las Vegas we're talking about, not Ontario, Canada. So I think that's perhaps what's going on here. I think Las Vegas is quite a warm place, so that makes better sense, especially in the summertime. It would be quite warm, quite hot. All right, well, yeah, that is all for solving the linear inequalities. Next time we're going to be talking about solving polynomial inequalities, so I will see everybody back for that day. Bye, everyone.